Dear students, let's proceed our lectures on the topic of considering tension processes in RLC elementary circuits, and it is for the case when the circuit is connected to the DC source. We have considered cases when aperiodic cases, it was cases when delta is greater than omega 0, delta is R over 2L, omega 0 is 1 over square root from LC. Such correlation of the parameters if it gives us delta greater than omega 0 or delta is equal to omega 0, delta is equal to omega 0, and we will have these cases when R resistance of the considered circuit is greater or equal to critical level. Its critical level is 2 multiplied by square root from L over C. We have the so-called aperiodic tension processes. It's such a processes when current does not change its sign. It's either positive or negative all time during periodic processes. Tension processes, and let's consider now case when delta is less than omega 0 and R is less than critical level, and we have here we have complex roots of characteristic equation. It's P12 equal to minus delta plus minus J omega C. J is imaginary unit equal to square root from minus 1. And in such a case, it was shown in previous lectures that I equal to I natural, because I forced will be equal to 0, and it will be equal to I maximum natural multiplied by e to the minus delta multiplied by sinus omega t plus psi natural. And we do know that I from 0 plus equal to I from minus 0 and equal to I maximum from here, I maximum sinus just for t equal to 0, just psi natural, and it is equal to 0 because RLC circuit was disconnected from the source in the regime before commutation, and therefore from here we can conclude that psi natural equal to 0. And we can write down that I equal to Im natural multiplied by e to the minus delta c multiplied by sinus omega c t. Omega c is equal to square root from omega 0 power 2 minus delta power 2. Let's take derivative from this expression. Di by dt will be equal to I maximum natural, yes, multiplied by, you see, we have here product of two functions of time, and derivative of product of two functions of time equal to first function multiplied by derivative of the second function plus second function multiplied by derivative of the first function. And it can be seen that in both cases, at taking both derivative, we will have such a coefficient e to the minus delta t, because derivative of exponential function equal to just to this exponential function, but it should be multiplied by derivative of argument. Here we have this derivative of argument multiplied by second function, it is first item, and second item it is just this exponential function, first function, it is before brackets, multiplied by derivative of second function. It will be derivative of sine is cosine, and it should be multiplied also by derivative from the argument. It's equal to omega c, it is here. And we should equate this di by dt to level of E over R at the moment t equal to 0. You see, at the moment t equal to 0, this item will vanish as sine of 0 equal to 0 and cosine of 0 equal to unit 1. So we will have here I maximum natural multiplied by this omega c, and e in 0 degree, exponential function 0 degree will be a unit. So just this product of these two coefficients. And from here we can write down that I am natural equal to E over L over omega c. And from here we can write down I equal to this I am natural, it's E. This I am natural, it's E over omega c L multiplied by E in the degree minus delta t and multiplied by this sinus omega ct, and with regard that psi natural equal to 0. We have such a function. And such an expression depicts damping oscillation with period equal to tau Tc equal to 2p over omega c. And tension processes here has an oscillating character, and it means that current will change sign during these oscillation processes, in contrast with these aperiodic processes when current does not change sign during all these tension processes. Here we have oscillating processes, but it is a damping processes, and when t tends to infinity, this current will tend to 0. Nevertheless, it is oscillating. It will be 0 at t tends to infinity, and we can conclude that duration of these oscillating tension processes will be approximately equal to 4.6 tau, yes, or it will be 4.6 over delta. In such a case, it's this graph. It was current through inductance and through other elements was equal to 0 before commutation, and the steady-state processes it will be also equal to tends to 0. But before these two states, we have these oscillation processes of changing of this current with period equal to omega c, which is equal to square root from omega 0 minus power 2 minus delta power 2, where omega 0 equal to 1 over square root from LC. It depends only on the parameter of this LC, of this RLC circuit. Let's write down now equation for voltage drop across inductance. It's UL equal to L di by dt. Let's substitute here got expression for current. It is here, yes. So it should be taken derivative from this expression, and as in previous case, we have here product of two functions of time, and when we have derivative, we should take derivative from the first item and multiply it by the second item, and then take derivative from the second item and multiply it by the first coefficient. So we do it this way. L, then I, it is you see, 1 minute, where it is, sorry, I is E over omega CL, this is coefficient, so it will be E over omega CL coefficient. L and L will be cancelled, yes, multiplied by E to the minus delta t, because this coefficient will be the same for both items of when we take derivative, yes, because derivative of exponential function is equal to exponential function, but it should be multiplied by minus delta by derivative of an argument and multiplied by sinus omega t. It is here, minus delta sinus omega t. Then derivative of second coefficient, it will be derivative of sinus is cosine omega t multiplied by omega c, derivative of this argument, and this coefficient will be before these brackets, omega c multiplied by cosine omega c t. We have such an expression for UL, and let's simplify this expression, write it in more compact form by usage such a triangular when we have omega c and delta as catetes and omega 0 as a hypotenuse, because omega 0 equal to square root from omega c power 2 plus delta power 2. And let's introduce here angle beta, which for this rectangular triangular it's equal, sinus beta equal to delta over omega 0, yes, and cosine beta equal to omega c over omega 0. And let's use such a designation to simplify this expression. For this we can we can transact this omega c. For this we can multiply and divide this expression by omega 0. Yes, it will be omega 0 in numerator. Here, you see, we have here L and L cancelled, E over omega c multiplied by omega 0, E in the degree minus delta t. And this omega 0, here it is in numerator, and here in brackets it will be in denominator. You see, it may be cancelled here, and here. But omega c over omega 0, it is cosine beta, and delta over omega 0 is sine beta. And we have here cosine beta multiplied by cosine omega ct minus sine beta multiplied by sine omega ct. And from trigonometry, it is known that such function equal to cosine of sum of these two arguments, cosine of omega c t plus beta, because it is cosine beta and it is sine beta. And we rewrite this expression in such more compact form. And therefore we can write down that UC equal to E minus RE minus UL, because E equal to RE plus UL plus UC. From here it is the simplest way to write it down. This EMF minus R multiplied by I it is equal to, here I it is equal to E over omega CL exponential function sinus. It is, you see, E over omega CL exponential function sinus, and multiplied by R, it's RI, and plus UL, and UL it is here E, the same coefficient E over omega C, E over omega CL, E over omega CL, the same coefficient, the same exponential function for UL, okay, the same exponential function, it may be put before brackets, and in brackets, instead of UL, we can write down this omega C cosine omega CT, it is omega C cosine omega CT, and it should be multiplied by by L, and minus minus here minus delta sine omega ct minus delta sine omega ct, and you see it is it should be you see we as we put this coefficient before these brackets, for UL it was not L here, but we can write it in this way. So it will be this common coefficient like here, and therefore we should put this L inside these brackets, and it is here, this L and this L. It may be, you see, it may be eliminated, but it's better to put it as a common factor. Then we can rearrange this expression. You see, we can multiply it and divide this expression as in previous case. When we got UL, we can apply the same approach to UC. We can multiply it and divide this expression by omega 0. You see, omega 0 appears here in this common factor in numerator. The same is rest is the same, and it's appear here in denominator. Yes, so it will be here R over it will be here R, or we can present this R through delta equal to delta equal to R over L. Therefore R equal to delta over to delta multiplied by L, and L is transacted also here in this. From here it is transacted here. Oh, sorry. So it will be R over 2 delta. It will be equal to 2 delta R over 2L. This L, R over 2L. R over this L, it will be 2 delta. This omega 0, it will be in denominator, sinus omega ct. Then omega c over omega 0, cosine omega ct. This L and this L, we transact this L. It will be L in denominator, L in denominator and L in denominator, L in numerator will be vanished, so it will be omega c over omega 0 cosine omega c, and then it will be delta minus delta over this omega 0, see, sinus omega c, and this we can, you see, here we have 2 delta over omega 0 sine and delta over omega 0 also sine with minus, so it will be just delta over omega 0 sine omega c plus omega c over omega 0 cosine omega c. And we can present delta over omega 0 as sine beta and omega c over omega 0 as cosine beta. And we may write it down. Here will be also cosine omega c multiplied by cosine beta plus sine omega c multiplied by sine beta. So we can present it as cosine omega c t minus beta for these items, and it will be e omega 0 over omega c multiplied by e z minus delta t. So it is we can construct graph which correspond to this case in oscillating processes. It will, this volume of UC will oscillate around its volume at t tends to infinity. It's this EMF, and it will be oscillate from 0 level, because for t equal to 0 it should be 0, just to level between these two exponential functions, e minus e omega 0 over omega c and e plus e multiplied by omega 0 over omega c. This graph of oscillation function of voltage drop across capacitance. And let's proceed next lecture, and bye bye for now. It was nice to meet you here.